In the question there is a cone, so we should draw a cone first. And then the vertical height is 24 while the radius is 18. And with the ratio 3 to 4, instantly we know that this is 3 to 4 to 5. So 3 times 6 give you 18, then 5 times 6 give you 30. But however, it's not needed in this question. Okay, afterward, this become two spheres. The smaller sphere plus a larger sphere with different size. So they have different radius and different volume. So what is the meaning of melt and recast? Which means before we melt it, the volume, and after we melt it, the volume should be the same. So volume of cone should equal to V1 plus V2. While V1 representing the volume of the small sphere, V2 representing the volume of bigger sphere. They didn't mention anything about the radius, but they tell us the surface area ratio is 1 to 4 times. So we don't have the volume ratio directly, but they try to tell us the volume the area ratio. So we intercept a little bit. Given A1 to A2 is equal to 1 to 4. It's because I defined the smaller one is V1, so that's why the smaller area should be A1, smaller to the bigger. And instantly we know that L1 to L2 should equal to square root 1 to square root 4. We can trace back the length ratio by taking square root, so therefore we have 1 to 2 here. Similar reason, V1 to V2. Then we just take cube. Then we can get V1 to V2. From the L1, L2, we know that the volume ratio should be 1 cube to 2 cube, which is 1 to 8. One easier way to use the ratio information is we just simply let V1 is 1 proportion while V2 is 8 proportion. So we can let V1 equal to 1K. At the same time, V2 will be 8 proportions. We can express these two items into one single unknown, so that it's easier for us to solve this equation. So after that, we are going to start from this equation. Volume of cone, we have full details of this cone. So we can write down 1 over 3 pi r squared times height. R, the base radius is 18, while the height is 24. Should equal to V1, we express it in terms of 1K. V2, we express it in terms of 8K. So divide both sides by 9K, we have pi times 18 times 2 is left times 8. 286 pi. Don't forget to answer the question. They're asking for larger sphere. So they're not asking about V1, but they're asking about V2. So we have to answer it V2. Volume of larger V2 is equal to A times of K, A's proportion. It should be 2304 pi cm cube. And then we finish part A, we are going to answer part B here. We are going to get the sum of surface area of two spheres. Then we have to use the volume, trace back what is the suitable radius to fulfill this requirement. And then when we get the R of the bigger sphere, we can also get the radius for the smaller sphere. So from the larger sphere here, we know that volume is 2304 pi, should equal to 4 over 3 pi r power 3 by the sphere volume formula. So we just solve the equation, divide both sides by pi, and then times 3 over 4. So we have 2304 times 3 divided by 4 equal to r power 3. We get 1728, and then to do the opposite, to remove power 3, we are going to perform cubic roots. Then we get r power 1 equal to 12. So this is R2 based on our definition, because we define the larger one is the second one. So therefore, we can do the same for R1, but you don't need to solve another equation like this. There is a more convenient method, is we have the length ratio already. So no matter what is the radius of the small sphere, it's just 2 times, then we become the largest sphere radius. So that's why R1 to R2 equal to 1 to 2. R2 is 12, so therefore R1 should be half of 12, 6. So the total surface area, the first one is 4 pi r square, while r for the first one is 6, and then plus another 4 pi r square, while another r is 12, which is 720 pi cm square. The question stated in terms of pi is okay, so this is our final answer.